This is my 3D graphics programming assignment. This OpenGL code sets up a simple 3D graphics scene using SDL2 for window management, Glue for OpenGL extension handling, and GLM for mathematics. Here's a summary of its key components and functionalities in the main CPP. You can view the classes and other CPP files while I show gameplay later on in the video. At the start, we have the header includes, as well as any libraries I will need in the main CPP. Then we define window size constants and a function for player movement, which I've created to keep the main game loop code body from being too cluttered. We then create our first vertex array object, as well as the window we will be creating the graphics scene in. This section initializes any objects we will have in the game. Apart from the UI objects, every object is either a member or is derived from the game object class, which has many useful functions for manipulating physical objects in my scene such as position, rotation, and scale. They also all use the same perspective shader. Each object is giving a model and a texture that it will be used during runtime. We next create our perspective shader and orthographic shader, the latter of which is used by the user interface. Below this is a body of code that initializes camera-related variables as well as damage buffers, which will be used to prevent damage being inflicted to the character multiple times per impact, should this situation happen. This section marks the start of the main loop. We set an SDL event for quitting the game and an unsigned integer pointer to get a player inputs. The player input function is also referenced here, which is defined below with each of the W, A, S, and D keys have their own direction to move the player, as well as the arrow keys to move the camera, independently of the model. This part of my code creates the matrices for the objects to be rendered by. We use model, view, and projection matrices to make the model feel and look 3D as much as possible when creating our work. This larger portion of the loop generally handles updating the objects in the simulation and rendering the objects to the screen. This part checks the collision of the bike and the cat in the simulation, and updates the UI accordingly based on the HP value of the player. Because the UI is not part of the game object class and cannot use a perspective shader, I have created an orthographic shader and implemented it here in my code. The end of the game loop is marked by the state reset of assets and memory used to clean up processes happening behind the scenes. This function uses the key state variable I created at the beginning of the file to update the position of the player and the position and rotation of the camera. Now I will show you a short simulation of how the game plays while other classes shown to the side. Thank you for watching my submission for the 3D graphics assignment.